Hello to everyone from Neuro-Bio from California. This is Greg Cole, and I'm shooting this video to talk a little bit about why I'm working with Neuro-Bio. Alzheimer's disease has been my specialty for about 35 years. We've been working together as researchers around the world to try to do something about this disease. Unfortunately, all the clinical trials from the last 10-15 years have failed. And we've not been able to successfully attack Alzheimer's disease by trying to address the amyloid and tau pathology that we know is used to diagnose the disease. Unfortunately, hundreds of millions of dollars, billions of dollars actually, have been spent on trying to find ways to deal with this disease, which is projected to cost trillions and trillions of dollars to the governments of industrialized nations around the world and to impact hundreds of millions of people. So we have a huge problem with nothing that's currently available. And that means we need to seek outside the box. We need to look outside the box where we've been focused on amyloid pathology and look for some other kind of pathology that may be more closely connected to cognitive decline. So Neuro-Bio has come up with one of these outside-the-box theories that takes off on the fact that the only successful therapies that we have been treating cholinergic deficits, and one of the big receptors for the cholinergic neurotransmitter acetylcholine is the alpha-7 nicotinic acetylcholine receptor. That receptor can have neurotoxic or neurotrophic effects, and its dysregulation is known to occur in Alzheimer's disease. So it's an accepted target for many of the drug companies to develop modulators of the activity of that receptor. The theory that developed by Dr. Greenfield and her colleagues at Neuro-Bio is that this alpha-7 nicotinic receptor is being acted on by a small peptide from acetylcholinesterase T14, which binds it and alters its activity in a destructive way. And what we've been doing is looking at the interaction between T14 and alpha-7 nicotinic receptor from patients who have Alzheimer's disease or who are clean controls, and finding that, in fact, there are differences in the binding affinity. The reason I'm working with Neuro-Bio on this project is because it provides an alternative view to the one that's been beaten to death and not gotten us anywhere. So I think that in the months ahead, we will be finding out how effectively targeting this interaction, this abnormal interaction that's found in Alzheimer's disease patients and in Alzheimer's disease animal models, will be relevant to therapeutic intervention. So that's why I'm working with Neuro-Bio. Congratulations on your new building, and I hope to see you all in the future in person. Bye.